everyone, we are going to discuss a coding problem in front of you. The coding problem is largest element in an array and the array is 132152. If you are sitting for any coding interview, then you have to drive your coding interview by yourself. If interviewer asked you any question, not particular this question, okay, you have any other question, you have to first of all you discuss the brute force approach of that particular question, and then you have to optimize your solution. Sometime better approach or solution exist or sometime not, and then you have to final optimize your solution, which is known as optimal solution. Okay, in this particular case, better approach is not exist. We have to start with brute force approach, and then we have to optimize our solution to reach optimal solution. Okay, so the brute force approach for solving this question is we have to sort this element. If we sort this element, the elements are sorted in ascending order. Okay, 1, 1, 2, 2, 3 and 5. And the largest element, first of all, what is the largest element in an array? Largest element is 5. So we have to answer 5. 5 is our largest element in this array. Okay, so we have to sort this element. The sorting is done in ascending order, 1, 1, 2, 2, 3, 5. Okay, and always if you sort the elements in ascending order, the largest element is always placed at the last index of that particular array. Okay, and if you are asking for the index of this element is arr.length minus 1. Okay, the length of this array is 1, 2, 3, 4, 5, 6, and if we minus 1 from this 6, we get 5. Okay, so 0, 1, 2, 3, 4, 5. The indexing of this particular element in this array is 5. Okay, we have to print arr of, let's suppose the arr dot length minus 1 is equal to में small n, and we have to print that particular index element. So print arr of n is our answer. Okay, and what is the pseudocode of this particular question? The pseudocode is, first of all we have to arrange this array in a sorted order. Okay, arrays dot sort arr, and then we have to print arr of array dot length minus 1. Okay, so this is the pseudocode for this approach, which is known as brute force approach, and then we have to move on to optimize this particular solution. Okay, if you are sitting for interview, then interviewer also asked for optimize this particular solution, because the time complexity here is big O of n log n, because the sorting algorithm takes somewhere around big O of n log n, and space complexity is big O of 1. So we have to optimize our time complexity. Now we have to move on optimal approach for this particular question, because at the starting of this video I already said to you the better approach for this particular question is not exist. So we have to jump on optimal approach. We have to first of all we are going to declare our largest element, which is ARR of 0 at index 0. Here the element is 1, so largest of ARR of 0 is 1. Okay, and we have to iterate these array elements to ask, hey, are you greater than largest? If yes, then update yourself. Okay, we have to iterate from another element, because this element is already stored at largest. So we are starting iterating from I is equal to 1. Okay, at I is equal to 1, the element is here is 3. Okay, here element is 3, and we have to compare these 3 with largest. If ARR of I is greater than largest, so we have to update our largest to that particular ARR of indexing. Here ARR of I is 3. We have to compare with largest. Hey, are you greater than largest? Yes, I am greater than largest. So update yourself. So we have to update this largest. Okay, we have to move this iteration to further. So I is equal to 2, and here the element is 2. Then we have to compare this particular ARR of I with largest. Hey, are you greater than largest? He said no, I am smaller than largest. So let's keep moving on, and then I is equal to 3. I is equal to 3, the element is here is 1. Let's compare ARR of I with largest. Hey, are you greater than largest? He said no, I am smaller than largest. So keep moving on. Then we have to move on. I is equal to 4, and here the element is 5, and we have to compare that particular ARR of element with largest. Hey, are you greater than largest? Of course, I am greater than largest. So update yourself. We have to update this largest to 5, and then we have to move I to I is equal to 5, and here element is 2, and we have to compare this index element to this largest. Hey, are you greater than largest? He said no, I am smaller than largest. So don't change yourself, and here the largest element is 5. Okay, as I already told you, the answer of this ARR of largest element is 5. Okay, so we have to print this largest element. Okay, so the code for this optimal approach is quite simple. First of all, we have to declare this array 1 3 2 1 5 2, and then we have to declare a largest element, which is ARR of 0, and we have to iterate by for loop. We have to start our I from I is equal to 1, because I is equal to 0 is already filled to largest. Okay, and then we have to move on I is equal to 1 to I is lesser than ARR dot length and I plus plus, and we have to compare if ARR of I, if are you greater than largest, then update largest ARR of I. Okay, and then finally print largest. Okay, so this is the largest element, which is 5. And this is the optimal approach for this particular question, and the brute force approach is already discussed. The time complexity for this particular code is big O of n, because we are iterating this all those elements in particular array by one. Okay, so the time complexity is big O of n, and the space complexity is big O of big O of 1, because we are not using any extra space to store our element. Okay, so this is the brute force approach and optimal approach for this particular question. Now we are meet in our next video. Thank you everyone for listening me carefully.